The third learning objective in section 4.3 is to test a claim about the difference of two means using hypothesis testing, including checking requirements, writing hypotheses in words and in symbols, finding the test statistic, computing the p-value and drawing the associated distribution, and writing appropriate conclusions. Here's the example. Researchers randomly divided 500 volunteers into two equal-sized groups with nearly identical average starting weights. One group spent 6 months on the paleo diet. The other group received a pamphlet about controlling portion sizes. After the study, the paleo group had lost on average 7 pounds with a standard deviation of 20 pounds, while the control group had lost on average 5 pounds with a standard deviation of 12 pounds. Is there a difference in average weight loss for the paleo diet and receiving information about portion control? So the group that just received information about portion control is our control group. We have a quantitative variable of interest, which is weight loss, and then we have two groups that we are comparing, the paleo individuals and those that are in the control group. This question doesn't actually ask for the requirements, but since that's part of the learning objective, let's talk about that first. The conditions that you need to check are, you need to have random. This is random because we have a randomized experiment. The researchers randomly divided the volunteers into two groups. We need independence in our observational units. Our 500 individuals is less than 5% of all people who might use the paleo diet or be in a control group, and so therefore we have independence of the data values. Number 3, normal population or large sample size for both groups. So we're taking the 500 individuals and dividing them up into two groups of 250 each, which is at least 30 for both of our groups. And then fourth, the two samples, the two groups, need to be independent of each other. These were individuals that were randomly divided into two groups, so there's no reason to think that they were related to each other. Since the two groups are different and unrelated, we could say that the paleo sample and the control sample are independent. Okay, going back to what we are being actually asked, Part 1 says, using correct statistical notation, state the null and alternative hypotheses. Because we have a quantitative variable of interest, weight loss, we're going to use the symbols mu in our hypotheses. So this is what they look like. The null hypothesis is that mu sub paleo is equal to mu sub control group. In other words, if we were to write this in words, we would say the mean weight loss for the paleo group is equal to the mean weight loss for the control group. The alternative hypothesis is that mu for the paleo group is not equal to mu for the control group. So notice the reason we're using a not equal to is because the research question talked about a difference between the average weight loss. So in words, we could say something like, the mean weight loss for the paleo group is different from the mean weight loss for the control group, as a way to write the alternative hypothesis in words. Next, the question asks us to report the test statistic rounded to 2 decimals. We will do this in GeoGebra. In the probability calculator, I've selected the t-test for the difference of means. The null hypothesis is that mu1 minus mu2 equals 0. Notice that if you add mu2 to both sides of that little equation there, you would have mu1 equals mu2, which is like how we've written it in our hypotheses. I've highlighted the not equal to button, since that's the symbol in our alternative hypothesis, and I've entered the data values. They told us that the paleo group lost 7 pounds with a standard deviation of 20, and there were 250 individuals in that group. The control group lost 5 pounds with a standard deviation of 12, and there were 250 individuals in that group as well. The output gives us the test statistic. Here's the t value, which is 1.36 rounded to 2 decimal places. The p-value is given right below it. P equals 0.1759. That's our p-value rounded to 4 decimal places. And we can draw a little distribution as this question asks us to. We're using the normal model. So I'm going to draw a bell-shaped curve. we have a claimed value of 0. That's the way that we would write our claim value for two means being equal. So mu1 minus mu2 equals 0 if mu1 and mu2 are the same thing. Our test statistic was 1.36, which is about right here. The p-value then, because this is a two-sided test with a not equal to in the alternative hypothesis, needs to include the area at that test statistic or further to the right, and also that same area in the left tail. So for a two-sided test, we will include the areas in both tails. And that gives us a p-value of 0.1759. Based on this p-value, since it is greater than an alpha of 0.05, we know that our results are not unusual under the assumption that the null hypothesis is true, and so therefore we will fail to reject the null hypothesis. How will we write our conclusion? Is there a difference in weight loss for the paleo diet and receiving information about portion control? Well, because our p-value is greater than our alpha, we will not reject the null hypothesis, and so therefore we cannot conclude that the alternative hypothesis is correct. In other words, we cannot conclude that there's a difference in weight loss for the two groups. It would be written something like this. No, since the p-value is greater than alpha equals 0.05, there is insufficient evidence to conclude that there's a difference between the mean weight loss for individuals on the paleo diet and individuals who only receive information about portion control.